Thank you for joining me in this video. In this video, I will teach us the factor theorem. Just unlike the remainder theorem, this one is the factor theorem. Let us refresh our memory a little from our last tutorials, which talks about remainder theorem, whereby we can have some factor f of x being divided by some linear factor x minus a, such that the result after division or the result of the long division, or division algorithm gives me some other polynomial q of x, plus give me another polynomial q of x plus r of x. That is the remainder. So that shows that be the case. Since we have this as our remainder, then this is not a factor of what? The f of x. So that is the idea of what? Remainder theorem. Now let's talk about what? Factor theorem. In algebra, the factor theorem is a theorem which connects or links factors and zeros of a polynomial. It is a special case of the remainder theorem. This theorem states that if there is some polynomial f of x, where f is the polynomial in x variable, and there is a linear factor x minus a, such that the division between f of x and what? X minus a is another word polynomial q of x, plus a zero remainder. Then x minus a is a factor of f of x, and a is a solution of f of x. So this is the statement of the factor theorem. Now, since you understood this statement, let us use two instances to back up our argument. Now, the one example is we have x cubed plus 7x squared plus 8x plus 2 equals to f of x. That is, f of x, it treats f of x equals to x cubed plus 7x squared plus 8x plus 2. Alright, now do you see that we are not given the linear factor, that we can be able to use to divide this. Now, how do we look for the linear factor? Actually, given the statement of the factor theorem, that so far, that linear factor x minus a actually divides evenly for us to have a zero remainder. Then this number here, minus a, actually is, but in this case it will be x equal to now a, will now be our word solution, So it shows that we can actually be doing a try and error method by what? Substituting any value of our choice, plus or minus of any value into this whole word expression here, and evaluate to see if we can have what? Zero, Any of the numbers that we substitute after the evaluation that give us zero is actually our word solution. And we rearrange to have the expression as our word factor. Now, let us start with let x equal to 0. Putting 0 in place of this here, and here. You can put 0 here. Putting 0 in the x variables here, we change the whole thing to return to 0, remaining 2. But 2 is not equal to 0. Then we do away with what? 0. Again, with let x equal to plus 1, let us put 1 cube plus 7 bracket 1 square plus 8 bracket 1 plus 2 is not equal to 0. How? Because 1 cube is 1. 1 squared is 1 times 7 is 7. Plus 8 plus 2. Summing all this will give us 18, which is not equal to what? 0. Again, we do away with what? Plus 1. Let us try with what? Minus 1, Now, let x equals to minus 1. Now we have minus 1 raised to the power 3 plus 7 bracket minus 1 squared plus 8 bracket minus 1 plus 2 is equal to 0. How? Because Given this as an odd number, when we expand -1 into 3, we shall also have -1. Given this as an even number is being expanded, okay, by -1, we shall have +1 times 7, which is what? +7 minus 8, +2 is 0. Why? Because -8 plus 2, these two here will give us -6, whereas -1 plus 7 will give us what? +6. Do you see that 6 minus 6 is now equal to what? 0. For that reason, s equals to -1 is our what? Solution. Okay? Or one of the zeros of what? The multinomial expression. Okay? Now, we say that x equal to -1 is one of the zeros, okay, of the expression, or is a solution. Now, let us rearrange, okay, to have s plus 1 equal to 0. Let us do away with this equal sign, okay, to have only s plus 1. Now, we shall take s plus 1 as our what? Divisor, as our linear factor, okay. Then we can be able to employ synthetic division, or simply we can employ long division method. But let me use synthetic division. If I should use synthetic division, then I will use this -1 to do my word division, okay. But if I'm to use long division algorithm, I will use this factor here, s plus 1, okay. So, but let me use synthetic. Now, by synthetic division, okay, I have -1 outside the line. Okay, the coefficients of these becomes 1, 7, 1, 7, 8, and what? 2. Now, bringing down 1, -1 times itself here is what? -1. Summing 7 and 1, 7 plus -1 is 6. -1 times 6 is -6. -1 times 6 is -6, okay. 8 plus -6 we give you 8 plus -6 we give you +2. -1 times 2 is -2. 2 plus -2 is what? 0, okay. So this is the 0 remainder in this case. So in standard form we have 1 times s squared is s squared plus 6 times s is 6s, then plus 2, okay. So actually this one is 0 over what? S plus 1, okay, which is still what? 0, all right. So do you see we have the other factor now, which is in a quadratic form. This now is our quotient, okay. We can actually further simplify this quadratic or using almighty formula or normal factoring method, okay. Let's do it, okay, so that we can be able to express the factors into 3 binomials, okay. All right, so this can now be equal to okay, fine. We can do it in this case because this is a monoquadratic. This last term here too has those two factors that we can sum to have was 6. Okay, so we can actually express our whole thing to be what's called f of x divided by x minus a will now give me this, okay, plus 0 over s plus 1, okay. So we stop here, all right. So we will plan to give us another clear example. So suppose we have s cubed minus 6x squared minus x plus 30. Now, we are not yet given a factor, okay? So we use try and error method to determine the factor, okay? Now, let us try, let us check if once we substitute 1, okay, starting from 0, we will not have 0, right? If we substitute 0 in x is here, we will not have 0 because 3 or 30 is not worth 0. If we put 1, okay, let x equal to 1, we put 1 here. 1 cube is 1. 1 squared here is 1 times 6 is minus 6, okay? 1 minus 6 is minus 5, right? Putting 1 here, over it will not give me what? 0. The same thing goes with what? Minus 1. So x equals to plus or minus 1, okay, is not equal to what? 0 when we substitute in this expression, f of x, okay? Now, let x equal to what? Plus or minus 2. Let's try with plus 2. 2 cubed minus 6 bracket 2 squared minus 2 plus 30. Let us check. 2 cubed is 8. 2 squared is 4 times 6 is minus 24. Minus 2 plus 30. Okay. Now, when we evaluate this, what do we have? 8 minus 24 gives me minus 16. Okay. Minus 16 minus 2 gives me minus 18. Plus 30 is not equal to 0. Okay, as it will give me 12. Now let's try with x equals to minus 2. Okay, now we put minus 2 cubed minus 6 bracket minus 2 squared minus 2 plus 30. Minus 2 cubed is minus 8. Okay, minus 2 squared is 4 times this will give me minus. Okay, 4 times 6, okay, will give me minus 24, okay, then minus 2 plus 30. I think this will give me 0. How? Because minus 8 or minus 24 minus 2 will give me minus 22. That minus 22 minus 8 here will give me minus 30, and minus 30 plus 30 is now 0. Do you see? We choose x equal to minus 2 as our word solution, or one of the zeros of the polynomial. Now, by successive division, we use minus 2 to do our division, okay? Writing out the coefficients of the expression given to us, minus 1, then 30. Okay? So, that will give me... No, sorry, I'm right anyway, but in my this thing, I made a mistake. Actually, when I put minus 2 cubed, minus 6 brackets, minus 2 squared, minus bracket minus 2, plus 30 is actually 0. Yes, okay, because minus here is plus, okay? So when I have minus 8 here I have minus 24, here I have plus what? 2, plus what? 30, okay, it's 0 actually, okay, because minus 24 plus 2 is minus 22. Then minus 22 minus 8 is minus 30 plus that is now what? 0, okay? So please just get a correction, okay? So now, having written this, breaking down 1, multiplying, I will have minus 2, summing together, summing down, I will have minus 8, multiplying together, I will have 16. Okay, summing down, minus 1 plus 16 is 15. Multiplying minus 2 and 15, I will have minus 30. 30 plus minus 30 is now 0, okay? Then I will have x squared minus 8x plus 15. Then plus 0 over what? S plus 2, okay? So we have a 0 remainder here. R of x is what? 0, okay? So we can further simplify this quadratic quotient here, okay? How do we do that? It's simple. Just look at this last term here, 15. Okay, what are the two factors that are the two factors of this 15 that when sum will give me minus 8, okay? I think the factors will be x squared minus 5x minus 3x plus 15. Yes, because minus 5x minus 3x gives me minus 8x. Okay, minus 5 times minus 3 gives me plus 15. Okay, so we bracket, we bracket this. All right, putting plus sign here in the middle. We have the common factor here, x x minus 5 minus, we take 3 out. Okay, cancel to have x minus, this is 5. Okay, we have minus plus minus 3 cancel 15 is 5. Okay, Then the factors now become, okay, the whole factors now, x plus 2. Then the factors of those quadratic now gives me x minus 3, x minus 5. Okay, in case you didn't see it well, let me clean here. Hope you've copied here. Okay, now I'm trying to write the factors now. Now x plus 2, okay, that is the first factor. X minus 3, x minus 5. Okay, when we expand these two, we have this quadratic. Okay, then expanding further with this binomial, we have the normal polynomial given to us. Okay, so this is actually the brain behind what factor theorem. So it shows that actually, since x equal to minus 2 gives us what? A 0 f of x after substitution, then that x plus 2 is now what? A factor. All right? Or like the remainder theorem. Okay, so have you seen you can actually differentiate between remainder theorem and factor theorem? Hope you found this helpful. Please do subscribe to my channel. Thank you for watching.